very well popular and very well known. And we will be basically seeing this case study as a face uh, landmark detection. Okay, so we will see some hands-on mostly. Okay, because that will give you a understanding of how, for those who are new to this entire field, those who are new to programming, for them as well, you can have an understanding of how the entire course basically happens, how, what are the takeaways. So at first we'll understand that what are the basic understanding of uh, uh, this landmark detection, what are the different algorithm prospective we use it, and next we will understand is what uh, algorithms we are using to detect the landmarks, and uh, how do we kind of define that. So it's a very long process, but we'll cut short to uh, define the space. So that is what is our agenda, so that we can finish everything on time and also get a better uh, explainability on it. So let me share my screen. Okay, so face landmark detection. Okay, so let us understand this deeply. What is landmarks, by the way? So whenever we are doing any kind of face recognition, right, uh, there are certain factors from each face. We take it and we try to measure that whether this face is equivalent to uh, another face or not. So let me take an example. So this is a face. Okay. Now, when I say that uh, I'm doing a face recognition, okay. So what we are doing primarily, we are taking all the features. We say it as a features from this face and try to compare this face with another set of face, another set of images. Okay, so this is primarily that we do it. Right now, when we do compare, we compare the attributes of this face. Now, when I say attributes, it basically means the pattern. Okay, the pattern which are present in this face, it's basically compared with the pattern of the other set of images. And wherever we see a match, wherever we see that the pattern are much near together, we say that these two faces are same. Wherever we see that the patterns are not matching, at that point in case, we see that the face is also not matching. Okay. Now, face recognition is very easy task. Okay, because we just need to compare. Uh, we need to derive the features. So there are a few steps. Step one is derive the features. When I say features, I mean the pattern. Okay. So derive the features from the face. Okay. This is the first step. Derive the features from the face. And the second simple step is to compare that feature. Compare the feature. Okay. Now, the way we derive is basically the technique is known as convolution. Okay, deriving the feature from the face. This particular technique is known as convolution. Okay, with the help of convolution, we basically pull out the features and then we try to compare. Okay, the features with other set of images. If there is a match, if there is a near higher probability that the two patterns or the two features are same, then we say that this face is a particular XYZ person. Okay. If the face is not matching, then we say that these two faces are not matching. So they are having a lower probability. Okay. So with the help of this, we basically derive the face recognition algorithm. Okay. Now I will come to the convolution and all of these bit later. Now let us understand, okay, that this is the basic structure. Okay, deriving the features from the face, and this technique is known as convolution, and then compare those features and figure out that whether it is a uh, relevant image or not. So this is primarily that we have been doing so far. Okay, but the most difficult aspect of this uh, entire face uh, detection is the facial landmarks, detecting facial landmarks. Recognizing the face is not so difficult, not so challenging, because it's been already there in the industry from quite long time. Okay, even your mobile phone is also using. But detecting the landmarks is very important. Okay, we can only detect the landmarks when we find those landmarks are available. So for an example, what are landmarks? The next question is, what are landmarks? Okay, facial landmarks. Okay, so first of all, you can see the eyebrows region. So this is one of the landmarks. You can see the eye region. So this is one of the, these are the landmarks, okay, which explicitly defines the attribute of the face. So the eye region, the eyebrows region, the nose region, okay, sorry, the nose region. So this explicitly defines the attribute of the face. The lip region, okay. Now, why do we need to understand these landmarks? There are a lot of industry application. I I believe that most of us are already being loving Marvel characters, right? Uh, we have Captain America, Spider-Man, okay, Thor, blah blah blah. We all are much fan of. There is a lot of technology that works behind those characters. Okay, so one of the technique is this facial landmarks detection. So the character who is playing that role, okay, the artist who is playing that role, basically have an opportunity to what they do is uh, they they do their normal expression, and those expression has to be stressed by these landmarks. Okay? So you the artist will perform whatever is required, what are the expression, whatever the action they have to perform, but we need to trace those action, those expression from the face, and need to fit it Guys, please don't do this. Okay. Please don't scrub on the Zoom meeting. It will actually annotate, and it will basically disturb the entire explanation. Yeah. Okay. So landmarks are basically those things which helps you to trace the entire attribute of the face. So as I was explaining, when a Marvel character is playing a role, all their facial expression get traced by these facial landmarks. Okay, these are our facial landmarks. Okay, so here we can see that this lady is laughing. Okay, is very happy. She's very happy and she's laughing, right? So this is basically traced by the landmark of the eyebrows, landmark of their lip region, landmark of her eyes. Okay, all the different attributes which are required is basically telling me that this lady is laughing. So here landmark represent the entire facial region, okay, including the contours of the face. We say it as a contour. Okay, this part we say it as contour, contour of the face, contour lines. So with the help of these contours, we come to understand the exact face region, and we try to fit those Spider-Man characters. Okay, eventually you have the Spider-Man character, right? And you actually try to fit the eye attributes with the Spider-Man character, the lip attributes, okay, with the Spider-Man character, the facial character. So that's how, and that's why we have this importance of face landmark detection. Okay, so we take the landmarks. We first try to learn the landmarks. Now there are different phases. I just told the applicability. It is widely used in the films industry, very widely used. Okay, widely used in trying to create a lot of emojis. Okay, you can go to Snapchat. Okay, mostly used by the social media platforms like Snapchat, uh, where you can see that there are a lot of funny, you can see filters are available. Okay, so these filters are nothing but they are the Snapchat filters. The Snapchat filters are stressing your uh, landmarks. Okay, and based upon your facial landmarks, those filters are getting added. Okay, so what we have to do is we have to understand that how can we derive these filters. There are multiple ways. What are the mathematical intuition behind it, and how can we develop that? Okay, with the help of machine learning, deep learning technique, how can we derive that? So it's not only about Snapchat. There are many other applications. In Instagram also there are many filters. In the current state of the art, AR VR is one of the booming sector where eventually all we are traveling through. Okay, so for an example, Metaverse. Okay, so most of you have heard about this Metaverse. Okay, and the other platforms like NFO. Okay, so most of you have already heard about this. So they are basically trying to create a virtual world. So this face landmark detection is only with face now. Okay, later on it will actually spread across the entire human body. Okay, so we will be trying to detect the entire body landmark detection, and which helps us to kind of perform the action what as a physical human being is doing sitting at one place can be reflected in any of the virtual models, okay, any of the virtual characters, okay, like likewise I was explaining that Spider-Man and or any given Marvel character, when they speak, they actually you feel like they're actually speaking like a normal human being, right? But um, that accuracy has been coming with the help of these landmarks, because at the back end, these Blender files, okay, these are known as Blender files. Blender is a tool through which we actually create these kind of characters. So we take this Blender file and we try to map the facial uh, landmarks on that particular Blender file, and then we try to see that with a real-time traction whether we are able to kind of map the different region of the face. Okay, just give me a minute, guys. Yeah. So now the next phase is we'll understand the mathematical intuition and then we'll get back to the coding aspect. Okay. So clear everything. Now, mathematically, okay, how do we define this? There are two aspects to it. First, every phase that we take, we try to plot the facial uh, pixels in a 3D space. Okay. So in a 3D space, we try to plot these facial attributes. Okay. Whatever we have seen, all these attributes, we'll try to plot it in a 3D space. Now, there is a reason of why we want to plot in a 3D space, because we want to get the real-time values. Okay. So we want to take the real-time values of how the values are there in a 3D space. Okay. So each of these I region will be represent, each of these region will be represented by a mathematical vector. Okay. So we have the x-axis, we have the y-axis, and we have the z-axis. Okay. So every region in this space will be defined by x vector, y vector, and I should say x, y, z, a complete vector. Okay. One particular landmark will be represented by x, y, z. Okay. And that landmark can be anywhere. Okay. Total, there will be one, this is equivalent to one landmark, one landmark vector. There will be, total 468 landmarks. Okay. When I say 468 means there are 468 uh, regions, you can say smaller regions, okay, which basically will get detected, okay, in this interfacial attribution. Okay. So each of these 468, there total, in totality, there are 468 landmarks. Each of these landmarks, okay, this can be a landmark, this can be a landmark, this can be a landmark. Okay. In each of these landmarks, we will basically get certain vectors. Okay. So this let's say this particular landmark, let me use a different tool. So let's say this particular landmark, from here, this is the x value, this is the y value, this is the x value, and its corresponding z value. Okay. So we get all the three different vectors, three different values, and combining those three different values, we get the vector of that particular landmark. Now, the reason of 3D space is any given module, everything is basically happening in a 3D space, right? Specifically the characters like Marvel characters, they all are playing in a 3D space, right? There is no 2D, then it would become a cartoon, right? But when you are basically trying to give a actual real feeling, then we need to kind of put it into a 3D space. Okay, so that our entire thing will come into a 3D structure. Okay, so this is how we are going to work. So now the question comes over here is, how do we basically determine these landmarks? Okay, what are the techniques applied to learn these landmarks? We can easily understand now here from this particular graph, or from this particular uh, axis, that there are three axes in a 3D space where all these landmarks are getting plotted, and the same 3D space will be used by the Spider-Man character, okay, and or the Batman, Spider-Man, whatever you say. The same 3D space will be used. These landmarks will be implemented on these landmarks of this Spider-Man or Batman, whatever it is, and what are the expression made by the actual face. So this is the real face. This is the real face, and this is the character face. Just a minute, guys. So we have the real face landmarks which are being carried out to the character face landmarks, and we basically plot it over there, and we try to kind of see that how well those landmarks are getting fitted. So this is the real story behind what you see in the Marvel character. Okay. The other part, another question is, how does we determine these landmarks? Okay. When I say how does we determine, means how do we train individual landmarks like this? Okay. How do we train these individual landmarks? Now there are multiple options to it. The first option is uh, we do annotation techniques, okay, which is a bit extensive and long process. What is annotation? We take some sample, let's say 1,000 images, and out of 1,000 images, let's say we take few samples near about 200 images. Let's say total population of image we have 1,000, and we are taking 200 images, and we are plotting those individual landmarks on 200 images manually. Okay, and then we are training our convolution neural network to identify each of these landmarks. Okay, so what is convolution neural network? So it is an algorithm which basically helps to train any given images. Okay, and when I say that training convolution neural network, it means that we are basically training uh, a network, a neural network, which has an ability to learn those individual landmarks. Now, what is neural network? Neural network is basically a similar network that is basically working in our nervous system. Okay, so the neural network helps in learning the different uh, landmarks which are present in different region, and then it helps to predict in any given image how the landmarks looks like. Okay, so this is, I'm trying to kind of explain in a short. Okay, but this process is very long process, and starting from each and every points that we can see here is a very long intuitive process. Okay, I'm just trying to give you the intuition of what we do. So a neural network is similar like a small kid. Okay, so the way you train, okay, just imagine when a small kids try to learn anything. Okay, they have a question on each and every aspect, right? So similarly, the neural network do have a kind of an understanding of each and every aspect. Okay, so once that kids get trained, they can basically say any given context, right? They can learn very easily, and because they have a lot of questions, because everything is blank to them, right? So once they start learning slowly at a different levels, they basically learn the smaller factors. Okay, because the neural networks is something that learn from a mass of experiences. Okay, so you don't learn anything in a day. So for an example, let's say if I ask you that what you had 2 days ago in your breakfast, you won't be able to remember much. Okay, or if I ask you that what you had, let's say 10 days ago in your breakfast, you won't be able to remember much, right? But if I ask you that what you had in your birthday, what you had in your breakfast in your birthday, you will be able to remember that. Okay, there are some special occasion. Okay, those occasions we can easily remember, but there are certain occasions where we cannot remember anything. Okay, uh, the normal days that we transform through, or that we travel through. Okay, so those days are basically not having certain weightage in our mind. Okay, until there is certain emotion, there is certain importance. Okay, you will be able to remember this particular day. Okay, because you are attending a workshop, maybe you are not attending every day, and this is something that new you are going to learn. So this particular workshop you will be able to remember, but a day before that, what you have done in these same time, you won't be able to remember, because that doesn't add any extra weightage to your mind. So these are the real-time intuitions that happens in human being, and we try to get it transformed into our algorithm. Okay, so a landmark over here has a different meaning than the landmark present over here, then the landmark present over here, then the landmark present over here. And each of these landmarks has a different purpose. So the landmark in the eye region have a different purpose than the landmark in the contour. This is basically the contour region. The landmark in the contour region has a different purpose. So we have a trained model, because this is a very time consuming project, because we are not doing a face recognition. It is very easy to do a recognition, as I mentioned, but very difficult to figure out these landmarks and map the real-time landmarks on a face, on a real-time face. So let's quickly jump into the practical part. Okay, this was all theoretical, and there are a lot of things that are still there. Okay, which we cover in our entire course. Okay, we cover the mathematical aspect, cover the algorithm aspect at a very minute level. This was just an overview of how things are, basically how they work, and we are going to see a practical implementation. So we have already a trained model which basically works for us, and which we have trained it. And now we are going to do the prediction, and we are going to see and try to fit in to our actual image or face. Okay, I'm going to fit it in my face and see how can we build that traction. Okay, so let's quickly jump into the coding aspect. Okay, let me clear my screen. So I will create a new Python file here. So for those who are new to the coding, there's nothing to worry. This is just we are trying to kind of build a quick prediction uh, part. Okay, we are not going to train anything, or not going to waste much of our time. So I will import. So at the first stage, we need to import relevant packages. So OpenCV will be helping us with taking a video and taking an image. Okay, then we will import some mathematical packages like NumPy. So import NumPy as npit, import pandas as pd. Okay, this is mostly for data mining purpose, pandas. Okay, uh, I'm not sure, but like whether we needed pandas, but still I'm just importing in case we need it. MediaPipe is our the platform through which we are going to kind of uh, uh, drive this landmark detection. Okay, and import time. Okay, so these are the things that we basically have it. Okay, so cv2 is basically opencv through which we actually derive it. NumPy is basically the mathematical purpose package where we deal with array related stuffs, as the way at the same time we do all the computation of linear algebra and statistics with the help of NumPy. Okay, rather than statistics, we don't do much, but linear algebra is something that we uh, kind of focus on. Okay, now why we need linear algebra? Because there are a lot of computation that we do on the vector aspect, because as I was mentioning, each and every landmark is a vector, right? A vector of three different space: x-axis, y-axis, and z-axis, right? So that's why we need the vector computation, and those vector has to be aligned in a certain uh, space, right? And that is what being done with the help of NumPy. Okay, now I'll just execute this. Okay, these are the packages we will take help of, and I'll execute this, and then we can see an image which is equal to cv2.read, and we can basically read a particular image. So let me read this image, this lady image, and we'll try to see whether we are able to read the image or not. So this is our path. This is our path. So cv2.show image. cv2.wait key. So while we read the image, we need to bit wait. Okay, because the pixels that are basically being read will take certain time to kind of uh, transmit through. Okay, if you don't pass this wait key, I'm passing 0 because I definitely don't need this. I'm passing 0. That's why. So I'm not willing to wait. So that's why 0 seconds. This 0 means 0 seconds. And I'm saying that once you get all the pixel values, just reflect that within 0 seconds. Okay. So this is my purpose. Okay. So now we can see that we have this image which is being read by our OpenCV. Okay. Now that's cool. Now we will directly jump into the code of landmark detection. Now, landmark detection will be done with the help of a online video. Okay, with the help of the video, because then only we can trace each and every landmarks at a proper way. When we say video, we basically will be using our webcam and we'll be shooting that video. Now, a camera has multiple properties to it. Okay, we need to understand that. One of the properties known as FPS. Okay, so if FPS, which we say it as frames per seconds. Okay. Now, what does it mean? Frames per second. It basically means that what is video, by the way? Let us understand a small understanding. What is video? Video is nothing but it is a sequence of your image. Okay, you have an image, it is just running in a sequence. So that is what is video. Okay, so each of these image is known as frames here. Okay, so when I say 60 FPS, when I say 60 FPS, what does it mean, by the way? 60 frames per second. Okay, means ideally 60 images per second. So let's say a video is of 2 minutes video. So each 1 minute is equal to 60 seconds. So 60 into 60. Okay. Uh, so now you have 60, 1 minute is equal to 60 seconds, and we have 60 images per second. So 60 into 60, which is 3600 plus 3600, which is for 2 minutes. So in totality, we have 6400 frames in 2 minutes video. Can you imagine? 6400 frames in 2 minutes video. Okay. So 60 FPS. FPS means frames per second. So 60 frames per second. A minute, 2 minutes basically will be defined as each minute is basically means 60 second. 60 second into 60 images, which is 3600 plus 3600 for 2 minutes, as we have 2 minutes. So 3600 plus 3600, we have 6400 frames in a small 2 minutes video. So this FPS we need to calculate. It is very dynamic. Okay, it is not every time that it will give me 60 FPS. Okay, so let us quickly get through the code. Okay, and understand in more deeper way. So the first thing is MP draw. I will take a variable. MP is basically my class, and then solutions, then drawing underscore utils. Okay, so this is one of the parameter. Before that, I will declare a time p time is equal to 0. Now, drawing utilities means I need to draw the entire landmark in a 3D space. So that is present in this particular class of solution and this package of MP. Okay. Now, what I will do is I will so drawing utilities contains all the different attributes of drawing. Okay. So over here, the same thing will be drawn on a face mesh. So the original attribute, so I will take it as face mesh, MP face mesh. So for those who are not relevant with Python or kind of starting their career in this, might face a bit of difficulty in understanding the code, but that's not an issue. You can just experience this as of now. Later on, once you enroll for the course, you will get end-to-end guidance on this. So don't worry. So MP solution face mesh is basically nothing but this helps to basically calculate the entire landmark's position. So it is calculating the landmark position. This is basically doing the this is basically drawing those landmarks. Okay, and finally, face mesh is equal to MP face mesh dot face mesh. Okay, and we will do maximum number. These are the parameters. Okay. So maximum parameter is maximum number of faces is equal to 1 as of now. Okay, I will try to detect my face. Minimum detection confidence. So what is this minimum detection confidence? This is equal to 0.5, means with a probability always between 0 to 1, probability ranges between 0 to 1. So if it is 50% that it is detected, if the landmark is detected at a score of 50%, we are saying that plot that landmark. If it is getting below 50%, then we are saying that don't plot that landmark. So minimum detection confidence and minimum tracking confidence. What is this minimum tracking confidence? This is also 0.5. Let's say if I'm nodding my head here and there, okay, the landmark also should be traced along with my different axes of face. Okay, so that is minimum tracking confidence. I will show you live. Okay, once I just execute this, I'll show you live. As of now, let's write the logic and then I will show you. So drawing specification. What is drawing specification? Drawing specification means what color of landmarks I want to make it, what will be the thickness and all. So MP draw, the drawing utilities, I am using these drawing utilities, dot drawing specs. drawing spec. Okay. Now here what we are doing, first of all, we will take some parameter called thickness, which is equal to 1, comma, circle the radius. Okay. Each of these landmarks will be a circle, a dot. Okay. So this circle will have certain radius. I will give a radius of 2 now, as of now. And then color. Color is equal to every image, remember this guys, every image is basically nothing but it's a combination of RGB. Okay. It's a combination of RGB. Okay. So red color, green color, and blue color. Okay. So every pixel is basically defined between 0 to 255. All the pixels are defined between 0 to 255. And we try to plot this, we try to take any facial image. 0 to 255 is my pixel values. And these pixel values are basically, we are trying to detect the landmarks from these pixel values. So these pixel values we are plotting in this 3D space. Okay. So RGB we are taking. So that's why we are providing the color. So color for RGB. So I will use yellow color. So 0, 255, 255. Okay. So these are my attributes of drawing specification. Okay. Now let me quickly write a logic for capturing a video. Okay. So capture is equal to cv2 dot video capture video capture of 0. When I say 0, it is using my webcam. Okay. So while capture dot is open, while capture is opened, okay, since this is a while loop, if my camera is working, if it is returning, is equal to capture dot read, okay, then results should get stored in face mesh dot process cv2 dot cvt color. I will explain it, guys. Just let me try to frame the logic. Yeah. So what we are doing is, if my camera is returning something, then I'm applying this face mesh dot process, means I'm processing that particular image, and I'm also doing a transformation. So this is basically OpenCV reads the image in RGB format, and then basically it reads in a BGR format and then convert into an RGB format, red, green, blue. Every image is being read in blue, green, red format, okay, BGR. Then we are converting into an RGB. So that's why we are converting from BGR to RGB while processing the entire video, and then we are plotting the image. Okay. So these are my results. Now, if results dot multi face landmarks, if results dot multi-face landmarks, means if there is a result, then what we do, we will draw the landmarks. So for LMS in results dot multi-face landmarks. Multi-face landmarks. Now we will draw it. Np draw dot draw landmarks, and draw these landmarks over the frame, comma LMS, comma np face mesh dot face connections, comma drawing spec, comma drawing spec. So what we did, we are drawing the landmarks, okay, by passing on all these landmarks over the frame. MP face base dot face connections, comma drawing spec. So this is basically the class which connects all the contour landmarks, and drawing specification we are passing it. Okay, so there are two kind of things we are drawing. One is the contour and another is the landmarks. Okay, so that's why we are passing it twice. Okay, now that we have already passed through this, the next thing is we need to calculate the FPS. As I mentioned, FPS. So C time is equal to time dot time. FPS is equal to 1 divided by current time. C time means basically current times, right? So C time, let me write this as P caps T. Makes it more easy for me to track it. So C time minus P time. So what we are doing, how to calculate FPS? Current time minus previous time. Okay. So we are calculating each time with the other, and then the previous time becomes current time. P time is equal to C time. Okay, right? And then we will put CV2 dot put text. We will put the text and we will put it on the frame, comma f of FPS. We'll do the formatting here. Int, I made a mistake. Int FPS. Yeah. Comma. I will give the position where to basically write this text. Comma. The font style. So CV2 dot font underscore Hershey's plain. This is the font style, comma 3. 3 represent the basically the you can say the bold, italics and all. Okay, so 3 represent the mode of the font. Then we will present the color. Color is yellow color 0,255, 255, and 3 again represents the thickness, the size of the text. Now, once we basically apply all of this, then if return, then cv2.inshow, this is for showing the image, myself, my landmarks, my base landmarks. Okay, we are just near to the end, and let's see how well we have done this. cv2.inshow, myself landmark detected, and if I need to also stop this, so I will stop this by hitting a quit Q. Okay, so by hitting a Q button in my system, okay, I will stop this entire landmark. So cv2.wait key, okay, because this is running in a while loop. So if I try to close the window, it will again come up. Okay? So that's why I need to write logic here, which basically, if I hit the Q button from my keyboard, that will basically stop the frame. Frame dot size is equal 0. Okay. So what we are writing, if the wait key is 1, and if I'm hitting Q icon, or my entire frame is null, if my camera doesn't work, frame will become null if the camera doesn't work. Then break the condition. Okay, else else over here, else break. Okay. breaking the first condition. That's it. Now capture dot release cv2 dot destroy all windows. Okay, so this is pretty much of our code. Okay, I will come back to this code. Let me execute and see whether is there any error I have made or not. If not, then the camera will open up. Yes, I can see that there is an error. uh, okay, we can see that bgr to rgb error. bgr, okay. So cv2, oh, okay, it should be color underscore rgb, color underscore rgb, bgr to rgb. Drawing spec, not defined. Okay. Drawing specs. There are smaller mistakes. This is small theta. Yeah. Cool. So you can see that it's basically tracking each of my face. Okay, each of my facial landmarks. Even I'm wearing specs, so I can, even though if I wear specs, it can able to track my facial landmarks. Okay, and even though if I don't wear, still it will work. Okay, and as I move my lip region, if you follow my lip region, as I move my lip region, all things are getting pressed. Okay, so even though I nod my head, so that is what is your minimum tracking confidence. You can see over here. So whenever I'm moving my head, okay, it's basically tracking all the aspect in a 3D space. Okay, so eventually at each and every aspect it is tracing. Okay, even my lip region, the eye region, the eyebrows region. Okay, everything is being traced. Okay, you can see that when I'm just opening my mouth, it's eventually tracing all of those. So, and you can now understand the 3D space all around. Okay, the 3D space comes over here. So this is your 3D space. Uh, just a minute. So this becomes your 3D space. This is your x-axis. This is your y-axis, and sorry, this is your z-axis. This is your z-axis, and this is your y-axis. Okay, now I am at a 3D space. All the landmarks are at a 3D space. Each of these landmarks will actually give a vector of x comma y comma z. It will create a vector of x y z, all these three different values. In totality, there are 468 landmarks. 468 landmarks present. So this is how robust the algorithm is. You can see FPS. Okay, FPS is basically frames per second. My camera is basically the webcam, and webcams are not that good, so it calculates only 30 to 40 FPS on an average. Okay, so it means basically 30 to 40 FPS means that there are 40 frames per second it is calculating, and sometimes it is in 30, in sometimes in 20s as well. So it depends completely that what are the different aspect your frames are in. So what we can see over here is 30 fps means the amount of time this video goes through, that will be basically 30 into the amount of time we are spending each and every second. We are getting this, so every second is getting calculated here, and we can see the fps value. FPS defines the clarity of the image. Okay, the higher the FPS, better is the clarity, better is the you can say the purity, means you can trace each and every action in a given image, in a given video. Okay, because what happens that your smaller actions are only being captured when you have a multiple images in sequence. Okay, I can see that eventually I can nod my head down and up. Okay, all these 3D space are working equivalently at the same angle, and you can see the tracing confidence is quite good. Eventually I'm nodding my head, and it's basically working at a very good levels. Okay. So this is how we actually work, but it is not only limited to what we have discussed. There are a lot of mathematical objectives, a lot of things that we have done to get this end result as a product. Okay, so yeah, this is how the facial landmarks works. Any questions? Any doubts? If I try to close, it will not close. You can see whenever I'm trying to close, it is not closing. Why? Because it is running in a while loop, and every time I'm trying to close, it is starting, the code is basically re-executing and starting off my window. So that's why I've written this logic that if I pass a Q button from my keyboard, then it should stop. Okay, so I will hit on the Q, and then you can see that entire video got stopped. Okay. So this is how the entire journey of facial landmarks. So yeah, anybody have any question, any doubts, you can raise, or else I will hand over the call to Kunal.
Are we done with this session, Rishabh?
Yeah, yeah.
Yeah, hello, folks. I hope you like this session. Do you have any queries regarding the session and content? Anyone wants to discuss anything with the Rishabh regarding the session, or anything are not he is not able to understand about the concept or the execution part? Anything about the roadmap? We are available at the moment. Anything you want to discuss regarding the your roadmap, your journey in the machine learning or AI space? Anything you wanted to know, anything you want to discuss, I would request you can unmute yourself for time being, and we can have a discussion. We can have a brief chat about it. Anyone wants to discuss anything?
Kunal, if I may, maybe I'll just jump in while folks are thinking of the questions.
Yeah,
Is that
please,
okay?
please go ahead.
So
Yeah,
first
please
of
go ahead.
all, a huge thank you to Rishabh. I mean, the way he explained this, it's pretty complex what's going on there, and he was able to break it down, this complex thing, into easier bits, and he explained all the aspects of how he went around, and then that the end result was the unique mesh where he's tracking 468 points, and he's showing that live. I think, to me, it was really fantastic, even though I'm familiar with data and analytics, but this is something very, very unique and fantastic. So I do want to congratulate Rishabh and his excellent session here. Um, I mean, maybe for the folks here who have joined and they're thinking, okay, this is really cool. It's not just cool. It is something at the cutting edge of this AI space, guys.
True.
I want you all to understand that Rishabh is someone, as he explained, he has patents in this field, and he has a lot of background in here, so he's able to explain it very easily and simply. But this is at the cutting edge, and companies and industries out there right now have many different kinds of images they want to analyze for their specific use cases. So this is a huge potential out there, guys. So just think about that. This is just one small aspect which you saw right now with the face detection. There are many other very cool as well as exciting and cutting edge things which you will learn in the AI modules. So any, any questions or maybe even ideas on where you think this facial detection can be applied outside of your iPhone and logging in? Anything other than that?
Rishabh, can you please look at the chat window? I think there are queries are coming on the chat window, so you can respond it to those queries. Do we require a strong coding knowledge to get better in this field? Query from Shivani. Rishabh, would you like to respond?
Okay. Yes, Kunal, can you just iterate the question because I don't see the question here. So strong coding knowledge.
So she,
Yeah, I got that question. Just the next question, just reiterate once. So strong coding knowledge is required. Otherwise, you will not able to kind of fix it. So at MCI, we actually train you first in Python and mathematics because there is a separate mathematics required to understand the data, to understand specifically this deep learning concept. This is not an ML concept, okay? So this is a DL concept, which is an advanced version of ML. So first you have to go through with programming, then a set of mathematical relation, because it is all about mathematics. And then you have to go through machine learning. And finally, you land into deep learning. So the output which you have seen so far is a deep learning execution.
Rishabh, Rishabh, I would request you. You can share your screen. I think we have designed the already content that we're going to cover up throughout our the program, so they would get the better understanding that how we have planned the roadmap for them.
Okay.
Our ML deal. So friends, be attentive for a minute. You'll get all the understanding, the kind of an exclusiveness we are bringing to the plate. We have planned in a particular roadmap, like even you are a raw or you are sitting at the scratch. I mean, you will be building everything from the scratch. There's nothing you have to worry about it. But although yes, you need to have a bit of an understanding, be it like a bit of a mathematical, statistical, and the programming knowledge. But obviously, we will gonna cover up. We understand that you guys are coming from diverse background and probably you might have not gotten a huge strong understanding about particular things, but yes, we'll be covering everything. We have designed a program in a way that that would take you to the professional standards, and like we'll be supporting by the KP for the next coming opportunities and the next mentoring rounds of sessions, or the support probably for your career portfolios or the other kind of stuff. Meanwhile, I think Rishabh will be sharing this stuff with you, so you'll get the better understanding that how what you need to get cover up throughout to achieve the proficiency in this particular MLDL domain, and how you have to go and do that. Is there any queries? Uh, when you receive the certificate, I think within 24 hours you'll get your certificates at your email box. Am I right, Anirudh?
Yes, you will. So you're talking about this webinar, right? Kunal, are you talking about this specific webinar? Yeah, the answer is yes.
Yes. Yeah, I guess yes.
Yeah.
Okay. Let me show you. So this is typically the roadmap that we have it. We start with the programming topics, and then we go with pre-processing technique. Okay. Then we go with the data manipulation, data wrangling, and all. And then we jump into the statistical part, okay, of the data. This entire, no, it's a long bandwidth that we cover all the statistical part, the probability, statistics, and everything. And after that, we move with data cleaning, handling the missing data, and a lot of things. Okay. Then we go with the data visualization. So it has multiple aspects. Okay. One aspect is we have certain tools like Power BI and all, but those are quite different applied in ML aspect. So then after we go with the machine learning algorithms, okay, where that's a huge bunch of algorithms that we take it. And this is a long journey altogether, from starting from this programming and then coming to this probability stats, the mathematics, and then cleaning the data, pre-processing the data, and then coming to the ML algorithms. There are a bunch of algorithms which we kind of learn, which we teach our platform. And once you are certified as an ML engineer, then comes your deep learning. Okay, so it's a second process. So in the deep learning, first you have to go with artificial neural nets. This is highly mathematics oriented, and you won't be able to understand until you understand machine learning. So that's the hierarchy. And then comes to computer vision, where you actually land into understanding this face recognition, detection, position estimation. And there are a lot of things like image segmentation, okay, image generation. Nowadays, AI art is one of them. So image generation, image comparison, and all of these, okay. Then after we land into natural language processing, wherein we go with uh, uh, going with basic understanding of the text. Okay, how can we add some weightage to the text? Going towards sentiment analysis, then understanding the sequence of the context. Okay, so then wherever the LSMs and all these lies, then we are going with a bad chatbot. Okay, and attention-based model. So this is your complete 360-degree, right? There are a lot of projects, near about 20 plus project that we will be covering over here, 20 plus industry relevant project. And in the deep learning aspect, we do have another 20 plus project. So 40 plus project you will be able to learn from here, apart from the capstone project that will be kind of conveyed separately. Okay, and those are all the real-time projects that we will be working. So that pretty much completes 360 view, starting from there are two certificate that is basically you need it to complete this entire AI portfolio, starting from machine learning, and then the next ladder is the deep learning. Deep learning is a bit complex. Until you understand machine learning, you won't be able to understand deep learning much better. So that's the hierarchy.
Great. Friends, we have built up the program in a couple of modules. One is the machine learning and other is the deep learning. So we wanted people to get mature into the machine learning first, and then probably they'll switch to the deep learning space. Regarding the certification, you will be getting the certificates in your email box in the next 24 hours. And we have shared the same link with you guys over the chat window so that you can enroll now to get the certification. Parallelly, I think we are about to launch our program in some days, like 2-3 days in a frame. So I would request those who are interested, please mark your confirmations in the feedback form that you are interested for the machine learning program, so that we are running a special offer for next couple of days for you all guys, so that you will get it at your email box itself. This exclusively offer will run for next 2 days. And those who are purely serious and interested towards building up your machine learning skills will be actually offering to them only. So please make sure that you track your email box for the next couple of days. If you are interested, please mention your interest in the feedback form that you are highly interested for the machine learning program. And then just a brief about it, the program will run for next 2 months in a row, and we'll be covering the many live case studies and the live problem statements with all the executions. And I think the Rishabh has already taken you through all the segments that we're going to cover up. So that will be somewhat like will be running for next 50 plus hours. You have to engage with us for the next couple of months. Do you have any queries regarding for the same? Yeah, cost of the program will be, you'll be getting an exclusively offer. Those who will be interested now. So our team will reach out to them over a call or over email. Those will be marking their interest in the feedback form that they wanted to join our machine learning space. So will we reach out to them and we'll give share the exclusively offer to them. So this will be an exclusively offer. We'll be releasing our generic offer after like a couple of days. As of now, if you're interested, please mark your presence or your interest in the feedback form, and then we'll be reaching out to you with the special offer. Anyone has any queries apart from this? Regarding the program or the roadmap or anything you want to discuss? Okay. Anyone, we are happy to hear from you all guys that how was your experience, or you can unmute for time being, share your experience. We'll be also sharing this live streaming link with you all so that you can go through it in case you missed out something. Anyone who wants to connect, they can unmute and we would be happy to connect and discuss further. Any query, if you have something in your mind or you are struggling with it, we would be happy to connect and discuss further. I hope you have got all the feedback links for the certification. Did you get all the certification link with you so that we can now conclude our session?
I just see a question here. Where can we use the certificate which are provided by you? And I am assuming that you're asking about this specific webinar certificate. So you can use this to show your employer that you have been engaged in continuous professional development. I believe most companies are looking and they expect their employees to continuously develop their skills. So this will go into that and will count for 1 hour. Also this goes into your resume and makes you look like that person who is continuously willing to learn, and that's what companies are looking for. And this is, by the way, not specific just to India, it's a global certificate.
Let's close the meeting now. I think we are done with it. And if anyone has any query, please reach out to us.
Thanks, everyone.
Thank you so much for connecting. Thank you. Let's wrap up for the day. We'll be connecting.